Hi guys, I am very much glad to explain the journey of building a wonderful trust bridge. So before going into the video, I am going to explain who are all my teammates. Now let's see our teammates. My teammates are Gopal, Tanish and myself Vishnut. And to make this video very much clear, I have segregated the contents of this video into 5 parts. So let's see the contents. Okay, the first content is how our team came up with this structure. So we made this structure through a SkySieve application, and then we constructed the trust page that only they are mentioned there. And also the second constant is construction of the trust pitch. So we construct the trust pitch through with the newspapers, and we construct the trust pitch. And next I'm going to explain about the team roles and the testing of the bridge, and finally the feedback. Now let's go to our first content. Our first content is how our team came up with the structure. So our team got inspired because of this K-Trust bridge. So with that we came up with this structure. Now Gopal will explain how we came up with this structure.
All right, so let's start. So this is how I came up with the structure of my bridge. When researching and looking at various types of the configurations of truss bridges, I found that K-truss bridge is highly durable and it's very efficient. But the purpose of K-truss bridge is that in real life, let's say this is, sorry for my drawing, let's say this is a K-truss bridge. Actually, let me draw it slightly better. The K-truss purpose of the K-truss bridge in real life is that you travel across the whole bridge. The car starts from here and goes. So every point on this bridge should be durable and like it should last. It should not buckle or it should not fade. But in this project, we were specifically told that the load that we'll apply will be particularly at the center. So I thought that why not let's try to design a bridge in which we can maximize the output only when the force is applied at the center point. And so what my basic thinking was, if you look at this, all these are compression members. All of these are compression members. And I thought, well, if we want to make the bridge more efficient, we have to decrease the decrease the length of compression members so that the bridge will last more. So what I did was, why not convert this K-truss bridge into something like this? You have this structure, and rather than this being a straight line, why don't I break it into two pieces like this? Similarly, this will be broken down to something like this. Now, all of these can be the midpoints, or it can like go slightly like this also. So if you see the report of a bridge, this team number 3, you'll find that in the SkySift structure, it's slightly like this. The curve is like this. It can be like this also, but then it makes no point because then both of these will be straight lines. It will be kind of like this, which defeats my purpose. I don't want this to be two straight members. I want it to be 4 individual members, which are joined something like this so that this both compression member length is decreased from a normal K-truss bridge now that we know the force is going to act in the center. And that was the basic idea behind it. I did some auditing and I played around with the SkySift structure and came up with the bridge idea.
Now, as you have said what Gopal had explained, and this is how we came up with the structure. And now I'm showing you the SkySteel bridge structure, and this is the way we came up with the structure. And the blue lines that indicates the compressed tension members, and red lines indicates the compression members. And this is the sky-seal bridge structure. And now we are going to the next part of the video, that is construction of the truss bridge. The materials we used in the construction of the truss bridge are old newspapers, fevicals, tape, scrap papers, scale, cutter, pen and pencil. Now I am going to explain what all the steps we have done during the construction of the truss bridge. First, we rolled the newspaper to create the truss members, and we also cutted them into its appropriate lengths with using the cutter and scale, pencil and pen to mark the appropriate lengths. And also we stuck them together using fevicol, and we also assembled the bridge, and also using the scrap papers we covered all the notes, and also using the tape we also covered all the notes. Now I am going to show you the model of a truss bridge. And this is the model of a truss bridge. As you can see, we have covered all the notes with the tape and the scrap papers, and this bridge at last became very stable. Now I'm going to explain all the member. Now I'm going to explain what we have done in the construction of the bridge and what are all the rules. Actually, all of us has contributed in all the works, and that's why we were able to complete this bridge. And also, some of us has contributed in some of the part of constructing the bridge. So as per that, Gopal had contributed more in bridge design, and Tanish in report making, and myself in trust member supply. And now I'm going to explain what I have done in the construction of the truss bridge. Actually, what I have done was I rolled all the newspaper into its truss members, and also actually I used two papers for tension members and three papers for compression members, and rolled them, and I cutted them into its appropriate lengths. And now I am showing the details of all the members. As you can see, the right box indicates that is, as you can see, the right side of this box indicates the compression members, the count of the compression members, and the remaining ones, that is 26 minus 22, that is the remaining 4 members are of tension members of this particular length 12.5. Similarly, I have cutted all the truss members to its appropriate lengths, and also I didn't cut all the members exactly to the lengths that is mentioned here. For example, for 12.8 centimeter member length, I have cutted it into 14 centimeter, so that while constructing the bridge, if I need more length, means I can use 14 centimeter rather than having just 12.8 centimeter exactly. After doing all the truss members into its appropriate lengths, also I have helped my team members in building the SkySafe bridge and not only this, I also helped my friends, team members in building the truss bridge and also sticking the bridge. Now I'm going to show we are coming to the next part of the video, that is testing of the truss bridge. So before testing, we used a rope and we tied the bottom so that we can place the weights below the bridge, and now we are going to see the testing video of the truss bridge.
5.5 I want order because the other one is I want 1 kg, 5 kg or kg? 6.2 kg now. My estimate of this 12.9 kg. Yeah. 13. We are going to 14. 19.8.
Here see the video, the estimated capacity was 5.5 kgs, but actually our bridge capacity was 19.8 kgs. So this is a testing results, and this way we completed the bridge model. Now we are going to the feedback. Now we are going to the feedback session. The mistakes and what we have to correct was we can decrease the weight of the truss members, because while calculating the ratio, that is what a bridge actually was able to withstand, and also what was the actual weight of the bridge, and that was the ratio. In the ratio, the main problem that decreased the ratio was the weight of the truss members, and we can decrease the weight of the truss members, and also the joints can be more strongly established, and also we can decrease the count of the members also. So these are the mistakes, and now I'm going to conclude this video. Thank you.